Okay, we've looked at linear inequalities and we saw that we could solve those just by doing ordinary algebra. Not so with quadratic inequalities. Okay, if we've got an inequality with an x squared in it, we must do the following. We have to use a graph. The kind of algebra we're allowed to do with inequalities is just too limited for solving quadratic ones. Okay, so we've got to start by sketching a graph. Before we do that, we check we've got a naught on this side, which I have. Okay, so I can afford to look at the graph, and the kind of things I want to show are the x-intercepts. So in order to sketch the graph of this, I need to think about the x-intercepts. So the x-intercepts are when y equals naught. Well, I haven't actually defined y, but this is what y would be. So x squared minus 2x minus 3 would equal 0. Okay, and how do I solve that? Well, I factorize it. So I do myself a little grid. So I want x squared, that's going to be x times x. I want minus 3. Well, how can I get minus 3? Well, I could try minus 3 and 1, minus 3x plus 1x, minus 3x plus 1x is minus 2x, so I've done it right. So I need x minus 3 times x plus 1 to equal naught. Notice I'm dealing with an equation now. I'm not dealing with that. This looks a little bit like this, but I'm finding the x-intercepts, the critical values where this equals naught, and I can solve it as a normal quadratic equation. My possibilities are x minus 3 equals naught, or from this bracket x plus 1 equals naught. So x equals 3 or x equals 1. So on my x-axis, okay, and I'd never normally need to bother with the y-intercept or the y-axis. The x-axis is what I'm going to be interested in. So I've got values 1 and 3. Now, which way does my parabola go? Well, I've got a positive number of x squareds. So positive number of x squared, it's going to be the U shape. It's going to be the smiley face. So it's going to look like that. Okay, so the first thing I do faced with a quadratic inequality is draw its graph, find the x-intercepts and get a decent sketch. Now I've got to decide where I want to be on this graph. So I wanted, okay, this thing to be less than naught. And I've now got the graph of y equals that thing, x squared minus 2x minus 3. So I've got to decide where this, what y is, less than naught. Okay, well, y equals naught on the x-axis. So where is y greater than naught? Well, points with a y-coordinate bigger than naught are above the x-axis, and points with y less than naught are down here. So I have to think, where does this graph go into the region where y is less than naught? And the answer is this bit of the graph. So I highlight, you can just scribble over the top. Okay, I highlight the bit of the graph I'm interested in. So that's a vertical decision because I'm deciding whether y is greater than, less than, or equal to 0. I want less than 0, so I want to be down here. So that's how I identify that it's this red bit of the graph. Now I look horizontally because I want to solve the inequality. I want to say what x has to be. So if I look in the horizontal direction, I can see that all the x's that apply. I mean, you may want to actually just imagine the x-axis part that corresponds to this bit of the graph, and it's this part of the x-axis between 1 and 3. I have to think about whether 1 and 3 are included. Well, they're not. The inequality said that y had to be actually less than naught, so this value at 3 and this value at 1 are not included because it's on the x-axis then, so I can put empty circles there. So to decode this picture, okay, the x's I'm allowed are the ones in between 1 and 3. And the way we write that is x in between 1 and 3, and x has got to be less than 3, and 1 has got to be less than x. These two signs always point the same way. There was just one highlight section of the graph, so there's just one range of x's, so I write the answer as 1 range. Okay, so that's one way these things could turn out, but please do watch the video where I show you what happens when there are 2 ranges for the answer.